Okay, I'm going to freshen it up with a little change of color. Write a two-column proof. Given the following information, that BAC, this angle here, is congruent to DAC. Okay, that's given. And also that DCA right there is congruent to BCA. So we can mark those and say that is congruent to that, and DCA that is congruent to BCA that. Okay? And we'll eventually be proving that side BC is congruent to side CD, and I suspect, haven't done this problem yet till right now, but I suspect that it's going to be something to do with the corresponding parts of congruent triangles are congruent. So when I say I'm going to change it up a little bit, what I meant is I'm going to write in purple. I haven't been doing that. So let's establish what we know. We've got angle BAC is congruent to angle DAC, and we've got angle DCA is congruent to angle BCA. How do we know these? Given information. They gave it to us, so we know it's true. Okay, what's the next thing we can do? Well, next thing we do is let's establish that this side is reflexively congruent to itself. Always fun when you have triangles sharing a side and we can use that reflexive property. I find it so pleasing. So, okay, we can say side CA, or you can call it side AC, is congruent to, and you can see how the line AC, that line right there, is the line of reflection. If we wanted the two triangles to land perfectly on top of each other, aligned perfectly, we would flip one over that line onto the other one. And so the vertices C and A will continue to be in position where they are. And so we can then say CA, side CA is then congruent to side CA. So those are, the vertices are also corresponding there. So what do we know? We know CA is congruent to CA. How do we know it? Through the reflexive property of congruence. Otherwise known as the reflexive property. You'll see it sometimes just written as the reflexive property. Okay, cool. Well, now that we know that, look, we have angle side angle congruence. So we can then say, let's call it triangle ABC. Triangle ABC is congruent to triangle. How do we do ABC? We go from this tip here out to the vertex that's away from the middle line and then down to this one. So here A would go to D, would go to C. A, D, C. And you can see how having them numbered on both sides is helpful, because now I've written at an angle and run it up, and I actually have to write 3 a little bit lower than where you see 3 on the other side. But we know they match. And how do we do that? How do we know those triangles are congruent? Through angle side angle. Great, because now we can then say BC is congruent to CD. Segment side BC is congruent to side, BC is congruent to side, I'd call it side DC if we were going to line them up. They call it side CD. I'll call it side CD because that's what they want us to prove, and it is side CD, but this is, it feels a little bit shady because we're really talking about going from B to C, from the outside vertex to the middle, and that should be DC, not CD. But I'll write it the way that they wrote it. It is still the same side. They still are congruent. That is congruent to that. And how do we know that? We know it because corresponding parts of congruent triangles are congruent. And let's call it good.